Well, hello and welcome to the webinar. Today we're going to be talking about data visualization techniques for cybersecurity analysts. My name is Dan Williams. I'm in charge of product management here at Cambridge Intelligence, and more about what we do later. So another title for this talk is this one: How to Make Big, Beautiful, Scary, Useful Pictures of Cyber Threats. The picture on the left is an example of the kind of picture we're going to be drawing today, and I think you can certainly argue it's big and beautiful. Is it scary? Well, that depends on what the data is all about. We'll find out more about the data behind this picture as we go. And most importantly of all, is it a useful picture? And that's really what we're going to be asking ourselves today. How can we make these visualizations not just big and beautiful, but also useful? So I'm going to start by talking a little bit about how you visualize a cyber threat. What's so difficult about cyber threats that requires this level of advanced visualization? Then I'm going to talk a bit about graph visualization. I know a lot of our regular webinar viewers are very familiar with graph visualization, but there will be some people watching this who aren't, so I'll give a quick introduction to the subject. And we'll spend the rest of the time looking at different visualizations of cyber threats, talking through some different examples and use cases from the real world. Just a little bit about us. Cambridge Intelligence is our company. Cambridge because we're based here in the UK in Cambridge, with an office in the Boston area in the US as well. And intelligence because we're really focused on the security and intelligence space. We help organizations such as law enforcement, intelligence agencies, financial institutions looking at fraud and financial crime, and cybersecurity companies looking at cyber threats and other aspects of IT or network infrastructure where you're trying to find suspicious activity, problems, or something unusual. We do this with two products, Keylines and Regraph. They're both developer toolkits that enable developers to build interactive visualizations of networks and connections into their applications. So you may not be familiar with us, but there's a good chance you've already used one of our products. These products are embedded into many applications out there in the market. Here are just some of our customers. It's a real mix of, as I said, financial institutions, governments, large tech companies, and other organizations. But what they all have in common is they have a large collection of complex connected data, and lurking within that data are threats, suspicious activity, criminal activity potentially, or fraud, and they need a way to find out what's going on in that data. So I'm going to show you today some demonstrations, some visualizations and applications that I've built using those toolkits, Keylines and Regraph. So back to the picture. How do we make these pictures and how do we prove that they're useful? Let's start with the question, how do you visualize a cyber threat? And in fact, before we even start there, because this is difficult, let's start with something even simpler and ask how you visualize something simpler. We'll talk about a bicycle theft. Here in Cambridge, we all travel around on bicycles, so it's a good example. And the thing about a bicycle theft, if I ask you to picture it, it's really not that difficult to do. I can imagine leaving my bike in the office car park and coming down at the end of the day, finding it missing. I can imagine somebody coming down the ramp to the car park, choosing a bike that they want to take, breaking the lock using some kind of tool, taking the bike, and maybe leaving part of the bike or the lock behind. Very easy to picture. I don't really need to think too hard about it. And because it's easy to picture, it's very easy to mitigate against it. We know exactly what we need to do to stop this happening. We can put a gate on the car park. We can put cameras up to monitor the bike racks. I can choose a better lock, lock my bike up better, or I can choose a less attractive bike that nobody wants to steal. I really don't have to think much about that. It's very intuitive to us. We can all imagine what this crime looks like, and that does make it easier to fight against. If we think a little bit about cybersecurity, the problem is much more difficult. Here's some typical cyber data. This is in fact a few seconds worth of data captured from my network card on my laptop, just looking at the various packets of data that have been going in and out of my laptop in a few seconds. It's very hard to understand. There's a lot of it. It's very, very low level information. And if I told you that somewhere in there was a cybercrime, I think very few of us would be able to spot it. understand what the problem was, understand what it's doing, and understand how to guard against it. So we have this fundamental problem that visualizing cybersecurity information, the data that lies behind cyber attacks, is really, really difficult to do. And when you look at it, it's simply not intelligible to most human beings. So the next question then is how might we visualize it? And this is not new. People have been trying to visualize cyber threats for a long time. The earliest example that I could find was the 1980s movie Wargames. Some of you may remember this one. It's full of fantastic visualizations of a cyber threat. This is a teenage hacker trying to get into the US Department of Defense, and he succeeds, and we see lots of pictures of nuclear weapons flying through the skies, and we have an interesting idea. The way to mitigate against this cyber threat apparently is to play a game of noughts and crosses against a computer, but these are very familiar images, and although it's kind of silly to be talking about Hollywood, there's actually a very good point in this, which is that Hollywood realized that if you're going to explain something as dry as hacking, this is hacking data. If you're going to try and explain that to an audience, you have to use some kind of visual representation to engage people and to help them understand what's going on. Nothing's changed. I found a more recent one. This is a chap who designs computer visuals for Hollywood movies. He's based in the UK, and this is one of his images that was used in the Bourne movie a couple of years ago. This is a scene where the CIA gets hacked by some mysterious hacking group in Russia, and we see lots of scary looking red lights and evil looking icons progressing from left to right across the screen as they break down the firewalls and get into the system. And it's all very contrived and silly, but at the same time, again, it is helping the audience understand what's going on. And if Hollywood had presented this as a sequence of IP packet data from a log file, I guarantee nobody would be going to watch that movie. So as well as being useful, visualizations sometimes do have to be big and scary, particularly if you're trying to persuade your customers to part with money against cybersecurity threats, then big and scary does help. But let's spend the rest of this talk talking about how we can make them useful. Now, if you're like me, you watched Bourne, saw this picture and said, oh, that's a graph visualization. Not everybody thinks that, perhaps, but it is a graph visualization, and I'm going to spend a few minutes now just explaining to those of you who aren't familiar with this what it means. So graph visualizations, graph technology is all about connections. Connections are absolutely everywhere. Every time you make a phone call, every time you send an email, you're making connections. And in fact, you don't even have to be consciously doing anything for connections to be made. Every time you walk around, your phone is connecting to different cell towers and Wi-Fi networks. Every single one of us carries a device which is constantly saying, hi, I'm here, who else is there, who are you, and connecting and exchanging data with other nodes in a network. So connections are absolutely everywhere, and within that connected data lies the traces of criminal activity, cybercrime, cyber threats, and so on. So how do we model connections? Well, let's think of a really simple connection. Dan sends an email to Claire. We can model this with what we call two nodes and one link. Dan and Claire are the nodes. The link represents the email. Links sometimes called edges. And what you have here is a very simple example of what's called a graph. A graph is a representation of data using nodes and connections. In this case, the connection also has a direction. The email went from Dan to Claire, so we can capture the direction of the arrow. But this is basically a graph, the simplest graph you can get. So what happens when we scale this up? Here is one of 44 pages of emails, and this is so each one of these rows represents an email that has been sent from one person to another. We have a sender name and a recipient name and some other metadata about this as well. And in a sense, what you're looking at here is a graph visualization. This is a visualization of connections, commonly called a spreadsheet or a table. Almost everyone on earth is familiar with these things. A spreadsheet is a wonderful visualization. Everyone knows how to read it. It's very good at performing operations like sorting. I could sort these by date and ask what was the first email that was sent. It's very good at filtering. I can say, show me only the emails that were sent by Timothy Belden, and it would filter down and show me only those. It's good at all of these kind of things. So there's nothing wrong with this as a visualization. But if I were to tell you that there was some criminal activity in this spreadsheet, or if I were to ask you who is the most senior person in this organization, looking at this table is not going to help you at all. So let's see what happens when we look at it as a graph. Okay, so I've loaded the data into the Keylines tool and displayed it with a few simple settings. Each one of these orange nodes represents one of the people in that list of emails, and the links between two people show that they've talked to each other. They've sent at least one email between them. Now, even with a view like this, we're already getting some benefit. There's a lot of technology behind simply choosing where to place these nodes on the screen. We call it a layout. And in this layout, we learn things already. We can see, for example, a very densely connected group of people in the bottom of the screen here who talk to each other a lot. And we can see someone at the top of the screen who's much more isolated and is the only connection between a little group of people and the rest of the organization. We can add a bit more color to this by choosing to represent the number of emails sent by the thickness of the arrow. So now we can see people who send a lot of emails have very thick connections between them. We can see that this person here, although they send a lot of emails, or rather, although they talk to a lot of people and they're a bit of a hub, they're not really sending very many. Whereas down here, Bill Williams is sending an awful lot of emails out and not getting very much in return. And you can probably learn an awful lot about team dynamics and management styles in this picture. This is a team that's very much one-way communication. Up here we've got a team where everyone talks to each other all of the time. I think most of us would probably choose which team they would rather be in. And it's quite fascinating to think that that information about the social structure of this company is hidden there in that data, in that spreadsheet. Nobody would have looked at that spreadsheet and spotted who is the best manager or who are the best teams for communication. It just isn't visible in that raw log data. We can go even further with graph visualization. The beauty is that this network contains a whole ton of information about the importance of the relative players, and we can visualize that using Keylines or regraph, in this case Keylines. What I'm going to do now is choose to make nodes larger if they are better connected. So I'm going to use a measure called eigencentrality, and what that's doing is saying, show me the most connected people bigger and darker so that I can spot them. And straight away I see that these people over here in the left, as we kind of imagined, they are the best connected people. They're the ones with the most connections, and they're connected to the most well-connected people themselves. That doesn't prove an awful lot, though. It could just prove that they like to talk. We might also ask who are the gatekeepers of information in the company. And I can use this measure called Betweenness, which scales the nodes in size based on how important they are to the flow of communication. If you took these people out of the network, if you took one of these people in the dense cluster out of the network, it wouldn't make much difference to the flow of information. So these people don't score very highly. But John here in the middle scores very highly indeed. If you took him out of the network, it would cause the most disruption. It would increase the length of paths between people by the most amount. And that means we can make a fairly good assumption that John is a pretty senior figure in this organization. And again, I just remind you, when we looked at that spreadsheet of data here, when we look at this spreadsheet of data, there's absolutely no way to tell who is the most senior person in this organization by looking at it. So that's an example of using graph visualization. We'll see a lot more of it, but the key point is that we can learn things you could never learn from a table or spreadsheet. And what has this got to do with cybersecurity? Well, hopefully you can imagine that since most log file data from your networks or from service providers or on the endpoints in your organization is of some kind of log form like this, there's an awful lot of information hidden in it that can be brought to life with the right visualization. So let's have a look at some examples. I'm going to cover three main areas in the kind of timeline of cybersecurity. We'll talk first about threat intelligence, trying to work out what's out there before it gets you. Then we're going to talk about threat detection and the SOC scenario where you're monitoring security in real time. And finally, we'll talk about after the fact incident investigation, forensics, and potentially even further areas like e-discovery and putting together information for perhaps use in court to prosecute someone after the fact. So we'll look at the full life cycle, and I'm going to just show you a few examples of how the graph visualization using Keylines or regraph in this case can help with these areas. So in cybersecurity, we need to decide what are going to be the nodes and what are going to be the links, and there's lots of different possibilities for it. You don't have to invent this for yourself. There are models out there already. This is just one of them, the Stix model. It's a model that tries to represent the cyber threat landscape using various different types of object. A type of object could be a piece of malware. It could be a particular threat actor, like an activist group or an individual. It could be a vulnerability, a known vulnerability in a piece of software or an operating system, or many other things. And these make perfect nodes in our system, and these things are all linked together. Malware, for example, exploits vulnerabilities, so we can easily draw a link between malware and vulnerabilities and have a look at what that does to the graph of our threat landscape. So let me show you that as a first example. Okay, so here's a visualization of some nodes. They're just lone nodes at the moment. Each one of these nodes represents a particular malware. This is a fairly old data set, but it serves our purpose well. And each of these malware nodes are known to exploit certain vulnerabilities. So I'm going to bring some more data into the picture here. I'm going to choose some technology that perhaps we're using in our organization. Let's pick something really old like Microsoft Silverlight. And as I add this in, what it's going to do is bring in nodes. These blue nodes represent vulnerabilities in Microsoft Silverlight. So I can see straight away that there's a bunch of malwares that exploit this vulnerability here. Whereas this vulnerability here only exploits a subset of them. So we have a kind of Venn diagram of relationship between malware and vulnerability. And as I bring in more old software, Adobe Flash, Internet Explorer, you hope you're not using some of these things in your organization, but many organizations do, and you want to know what you're at risk of. And now we start to build up the threat landscape, and we can see the areas. This is our threat landscape. These are the vulnerabilities. These are the things that are going to attack them, and this is the impact it would have if we managed to eradicate all uses of Internet Explorer in our organization, for example. Here's another example. This is a data set of data breaches. Each one of these gray nodes represents an organization or institution who has acknowledged that they had a data breach, and we're capturing information about the nature of that data breach. There are different ways this can happen. It can happen because an activist group, this node represents activist groups like Anonymous, they can attack you and target you directly. Or perhaps another example might be a former employee, a disgruntled employee perhaps, who doesn't have access anymore and chooses to publish a bunch of data that they shouldn't have. Lots of different ways in which data breaches can happen, different attack vectors. And we can explore those attack vectors again using the graph. So if, for example, I look at only the red connections represent, in this case, advanced technology, basically hacking tools or malware. And we can see that the bulk of the red activity in this chart is centered on the activist groups. They're the ones who are making the most use of advanced technology, whereas other types of data breach, such as pure carelessness, people leaving a spreadsheet open for someone else to steal, that's not the kind of way Anonymous operates, but data breaches which have been carried out by perhaps a regular employee who just stumbled upon some data that was left unattended might fall into that category. And you can imagine looking for, what other companies are like me, like my organization, and then trying to understand from this picture what are the most important threats out there that I need to worry about. Again, very useful use case for graph technology. As a final example, remember that this information doesn't have to come from outside your organization. It could come from inside. This is a kind of a bit of an abstract topology of various pieces of infrastructure in my organization, servers, disk drive, services, and so on. But it also has information about business functions in the company. And I might want to ask, well, what does this business function depend on? And as I click one of these nodes, I can start to follow the dependencies through this graph. You're seeing a brand new feature not yet released in Keylines and Regraph, this visualization of curved links in a left to right sequential layout. And I can explore this layout. I can say, okay, this business function depends on only one service, but that service depends on a certain host. It makes use of this server, as do all of these other hosts. And I can follow the dependencies through and just understand exactly what parts of my infrastructure influence or are required for this business unit. If one of these became compromised, what other parts of the organization will become compromised, and so on. So threat intelligence can involve looking inside as well as outside. And again, a mass of connections exists that can help you navigate that landscape. So we're now going to move on to the next area, which is live real-time threat detection and security monitoring. And the challenge here is a slightly different one. The challenge here is that you need to be able to understand what's happening. So here's an example of something bad happening. Perhaps there's a device in one of my factories which has suddenly, or in my infrastructure, which has suddenly started communicating with the public internet in a way that it's never done before. That's a great indicator that we've got a problem. But the challenge, is this is just one node out of many, and how can we understand the important stuff when it's buried in a sea of everything else that's going on? What you see at the bottom here is something we lovingly refer to as a hairball. A hairball is what you often get when you first attempt to visualize heavily connected data. And the challenge here is seeing through the hairball and finding out what the important stuff is that you need to worry about. Now, there are many techniques for doing this. I'm just going to show you a couple. So the first example I'm going to show you is this one. It's a technique called aggregation or grouping. We call this feature combos in Keylines and Regraph. And what we're doing is we're showing a high-level representation of the network first. This is maybe the view that you're going to get in your situation room. We can see that there's a problem in Edinburgh, and we can see that there's a problem between Paris and Cambridge. Very easy to see that at a very high level. Makes life very easy, and I can drill down. I can say, well, okay, what exactly is this problem in Cambridge? And I can open up the network and see that, in fact, Cambridge is really a shorthand for describing these four networks. And I can see now that the problem comes from this one at the top. If I open that, I can see that in fact was just shorthand for a dozen or so actual nodes. And now I can see exactly the endpoint that's causing the problem. I can click on it, I can get context, I can understand exactly what's going on at the very granular level of these individual nodes, but I haven't lost the overall context. I can close these up again at any time and go back to the full network view. This technique is really, really powerful because you can represent hundreds, thousands, tens of thousands of nodes in this way, allowing users to drill down when they need the detail without overwhelming them with a hairball when they first look at the big picture. Here's another example which goes one step further. In this case, we've taken that network and we've overlaid it on some imagery, in this case a map of the world, to help bring context to what's going on. Remember I showed that example of something in New York talking to the public internet that it shouldn't have done. At a high level picture, I can see that very clearly with this link. If I double click, in this case New York, I zoom into New York, and you can see that as well as showing the sub network behind it, I'm also showing the nodes laid out in context, in this case on a kind of a floor plan, and I can find out exactly which asset, which bit of my infrastructure, which machine, if this is a factory example, is communicating with the internet that shouldn't have been doing it. Again, it's slick, it's pretty, you could argue it's a kind of eye candy, but it's actually really, really important for people responding to live situations to be able to get very clear context and understand what's going on quickly without being swamped by a sea of information that isn't relevant. So that was just two examples using aggregation and using maps or imagery as context to help people understand what's going on. There are many more, and we have many other webinars on reducing clutter and helping to simplify the big data problem that you can see here. I'd like now to move on to the last of our three areas, which is incident investigation and forensics. And again, there's far too much to talk about here than I can fit into this short webinar, but I want to give a couple of examples of the kind of investigation that a graph visualization can help you with. Usually when you're doing some kind of investigation, you're interested in understanding the who, the what, the where, the when, and the how. There's plenty of material about the best ways to perform an investigation into a cyber threat. I'm going to just talk about one of these, which is the when. And the reason I want to talk about it is because I haven't really talked about it so far. Most of these connections, in fact, pretty much every one of the connections that I talked about will have some kind of timestamp associated with it. You have a huge amount of metadata at your disposal, which gives you time context of your data. When Dan sent the email to Claire, that email will have a timestamp. In fact, it probably has several: the time Dan sent it, the time it was relayed from one server to the next, the time Claire opened it. All of these timestamps are there and can be made use of. So we can use Keylines and Regraph to visualize time. A little image here showing you one example of that. This is showing a very visual example of the spread of, in this case, a ransomware which is being spread and appearing on many different host machines over time. On the bottom you can see our time bar feature, which is bringing in data in real time and showing you the kind of distribution of attack pattern. And in the top, you're seeing one of those aggregations, in this case representing infected machines in Russia, and we can see the spread of the infection over time, and we can try and work out what happened next, and so on. This visualization is very simple, compelling, and you would not have been able to understand this behavior simply by looking at a long log full of timestamps. Now, I promised I would come back to this picture that I showed you at the beginning. In fact, what this is a picture of is just 6 minutes of one of the blocks in the Bitcoin blockchain. I'm not going to do a webinar on cryptocurrency, but just basically what's going on here in the world of Bitcoin. The Bitcoin information is all captured in a public ledger. You can all access it. It's available for everyone to see. It's famously anonymous, but just because it's anonymous doesn't mean it's not public. We can all access it. And it's basically made up of transactions. And a transaction takes a bunch of inputs, which we represent with these blue nodes, and at least one output, which are the yellow nodes. And sometimes, or quite often, when you send money, if I send money from my blue collection of money to somebody else, I'll get a little bit of change back. So this yellow node here in my collection represents the change I received back from that transaction. So here's that visualization live in Keylines. On the bottom I have my time bar, and if I were to, for example, zoom into a particular point in time, this is just within those 5 or 6 minutes the data comes from. I can see the various patterns of activity, and as I move through time, you can see the constellations of stars in this beautiful visualization twinkling as various transactions are affected. Let's take a look and see what's lurking within this data set. So if I zoom in, first of all, we can look at an ordinary transaction. Here's a typical transaction of the kind I was talking to you about. I have some inputs, this blue. The transaction sends it to somebody else, and I get a little bit of a bit of change back. So this might represent me, and this might represent somebody I'm sending some money to. That's a typical picture, but there's some other interesting shaped creatures lurking in that picture. Here's one that you might have spotted. It's a very large structure, and this basically represents two transactions that have transferred a very large amount of money. If we click on one of these transactions, we can see the one on the right was for about $25,000 at the time, and the one on the left was about $47,000. So an awful lot of money moving around here. And we can see in order to transmit that large amount of money, a huge amount of inputs had to be collected together to form that transaction. Here we see another transaction or collection of transactions that's also very different. In this case, what we have is a sequence where a small amount of money has been moved very quickly. This is all taking place in a very, very short space of time through multiple transactions. And even more curiously, we can see that there are certain addresses in this sequence. Here's one here that's being shown in green, which appears again later on in the sequence. Here it is again. And that's why I can produce quite a nice visualization of kind of folding this sequence up on itself. You can see that happening here using keylines. And we can see this loop, and this loop is very interesting. It's basically showing money going from someone, going through a whole sequence of different places, and then coming back to the same person again. Now, does this represent some kind of nefarious activity, some money laundering system perhaps? Or in fact, is it something entirely innocent? This could be an automated process, perhaps some kind of security measure designed to protect and secure the funds in a wallet by moving it around to multiple addresses. I don't know. I'm not going to go into any more detail on the details of this one today. But the key thing is that in order to understand cybercrime, you have to understand the way cyber criminals are working. Cryptocurrency is a great example. The proceeds of crime, payments from a ransomware, or transactions on the dark web, whatever it is you're investigating, you need to understand this world. And if you can imagine that this is only 6 minutes of just one Bitcoin block, you can imagine that trying to understand that without a visualization is going to be really, really difficult indeed. This is not like the bike theft. You cannot just picture the crime in your head and understand what you need to do about it. This is much more obscure and low level and difficult to understand. So by way of conclusion, let me say that again. I believe that the data in which cyber threats or cyber crimes appear is just not consumable directly by humans. I don't think it's possible. There's a small number of us maybe who can read the matrix and understand this stuff, but for most of us, we need effective, interactive visualizations that help us explore and play with that data. That's what's going to help us understand it, and that's what's going to help us deal with these threats. And today, you've seen a few examples of those visualizations. You can embed those visualizations into your own applications. We have Keylines and Regraph, which help you do that, and they are available for a free trial if your development team would like to play with them. So that's it. Thank you very much for listening. My contact details are on the screen, but if you do have any questions, please do put them in the comments and we will answer them as soon as we can. Thanks very much for listening.